Welcome everybody to our session here. It's the Technical Empowerment Series where we're going to be talking about storage. I'm your host, Fabian Duarte, Associate CTO for Infrastructure Modernization, Enterprise Storage, and Business Continuity at SADA. Today we've got a phenomenal guest. I'm very excited because he comes with this wealth of knowledge on storage. Long-time storage person like myself, more than 20 years in the industry, comes from amazing places. Like if you've ever heard of Extreme IO, if you've ever heard of IBM XIV, he's been there, he's done that from before the product was made until where it is today, where it's become kind of a staple and revolutionized the industry. He's nobody else, he's the most important person that I'm going to be talking to today. His name is Shimon Ben-David, Chief Technology Officer at WEKA. I'm going to let him explain what WEKA does. I'm pretty impressed by it. I think it's a ton of fun. I think it's a solution that becomes very innovative. And again, if you've been in the storage industry for a very long time, you realize that there are technologies that become cutting edge that reshift the entire industry in where it's going. And it gives us the opportunity to explore the way to achieve net new performance on workloads that are pretty much net new as well. So without further ado, Shimon, feel free to introduce ourselves and let us know a little bit about you.
Brilliant. Thank you, Fabian. So nice to meet you. My name is Shimon Ben-David. I'm the Chief Technology Officer at WEKA. As you mentioned, been in the storage industry for ages. We actually did XAV, as you mentioned, a part of the IBM that was then sold to IBM in 2007, actually with the same founding team of WEKA. That's brilliant. We're working together for all of these many years. And actually, when we'll talk about WEKA, we took a lot of the decision points, the do's and don'ts that we saw at XAV, and we implemented, obviously, the do's at WEKA, and we'll talk about that. Simplicity, management, ease of use, software defined. I've been through the Extreme IO acquisition to EMC. That was very phenomenal. It was a great product. And then actually regrouped with the same guys to do WEKA.
It's always great when you're band together with a group of folks that understand the storage industry, that understand the direction it should take, and then understand the current challenges that are limiting certain types of workloads that are coming in. So with that in mind, what is it that WEKA does?
So what is WEKA? WEKA is eventually a data platform. And when I say a data platform, there was always like, well, what do you mean? So a data platform, the WEKA data platform, is actually composed out of multiple components. One of the biggest components is the file system. So we created our own file system. We designed it from the ground up. It has nothing in common with other textbook parallel file systems or filers or NFS file system. It's our own file system. Eventually, it's consumed in multiple ways, multiple protocols as a regular file system, but under the hood, it's completely different. And in actually being completely different, it allows for things that are usually not associated with file systems. I'll give you some example. Massive performance. So we're doing IOs at the 120 microseconds for a file system. That's inconceivable in many ways, but we're doing it.
You know, when I first came across the WEKA platform, one of the things, having been a storage administrator for many number of years, being very familiar with the three top pillars of storage, right? You have, well, four if you count Kubernetes now, but you have enterprise block storage, you have NAS, you have object storage, and then you have, well, what's now Kubernetes-based storage. But when you look at these worlds, all of them were independent of each other. If I had my NAS device, I had to have special tooling to move my data to object. And even today, when you go look at Linux file systems, right, or Windows file systems, you always need either you have a direct protocol like SMB or NFS that it mounts it. But if I have my data living in NAS and I move and I need to access it as an object, I've got to put a server on top of it to get into the data, or I've got to go use a tool like Fuse, which has its performance limitations, or Cloudberry, you know, all of these different tools. What I really liked about it was, if you look at it from just the storage administration perspective, I'm going to give you a traditional NAS mount point on your server so that all my folks that are system administrators can connect it, connect their instruments, feed data in there at high speed, high performance, right, line rates. But then for all of my folks that are developers, data engineers, that aren't used to these rigid setups of server storage, they can just come in with an API and access the exact same data, which just kind of unlocks it. And then, okay, great. Now I can access the data. What I find fascinating is the portability of the data. So now it's no longer confined to like data center, or it's no longer confined to a region in Google Cloud. Now I can go out there and massively distribute my data anywhere I need, because the fact is like the future, which is now, we're accumulating tons of data that needs to be analyzed, that needs to be unlocked, that
Brilliant, yes.
needs capacity efficiencies, that needs tiering, extensibility. That was what drew me to this platform. How are you seeing that customers are now leveraging what I just, kind of geeked out on
Yeah.
and using it, let's say in like life sciences?
So it's interesting, and I'll touch on something that you just said. Customers are now moving to pipelines. So in the past, I had servers, I accumulated data, I analyzed the data on the servers, and that was the method, whether it was life science, financials, EDA, other environments. Now, what we're seeing is that customers are generating data in some fashion, analyzing the data or pre-processing or ETLing the data in another fashion, and then training or actually processing the data in another fashion, and then trying to archive or back. Right? It's a pipeline of steps, and as you mentioned, it was always a game of compromises. It was always I now need to create the data in some fashion, put it in some blob environment or some object storage environment because of the capacity, and then take part of it to some other storage environments in order to process it, and then maybe even copy it to my local NVMEs of my servers because that's the fastest you can get, right? It was always a game of, from the moment you took the data until you got into some insight, you had to massage it, move it, you had to maintain and orchestrate multiple storage environments. So the way customers are consuming WEKA actually now, I'll preface it by saying, when we say accelerating the time to value, it's not only because we're ridiculously fast. It's also because of the ability to say, look, Mr. Customer, you have your pipeline. You don't need to copy your data constantly between your different components in order to go through that pipeline. Throw the data using any protocol to our WEKA environments, whether we see cryo-EM scopes, genomic sequencers, EDA machinery, manufacturing lines, autonomous environments that are just sending IoT data into the environment. So throw the data into a WEKA environment, whatever way makes sense for you, and then just pre-process and analyze and compute on the data without moving it. Because if the promise is the storage environment is as fast as your local NVMEs, or actually much faster, then why would you spend the time of also copying it to other locations? And then at the end of that, and that's becoming more and more important, how do you retain that data for the next experiments, next projects, for accountability? So the ability to handle that data at scale means that if now I have tens of petabytes or exabytes of data, now I can just say, hey, WEKA, take snapshots of that data, push it to a cloud environment, to another AZ, to an on-prem environment, retain it somehow, in a way that it's always referenceable. And then when I need it, I'll have it. And not a lot of people think about it, but also trying to retain the data at scale is not like a simple backup environment, right?
No.
You need to go over millions of inodes or billions of inodes, actually see what changed and do that. So kind of like to go back to your question, how customers are using it, they're consolidating their multiple data ingestion environments, their multi pre-processing and processing environments, and GPU analysis on the same data, just by not moving it and computing on it on the system.
Yeah, I mean, we come across problems where, we get the question, how can I discover all of the objects inside of my buckets, right? Well, it's very easy if you've got, a million objects, but when we're talking petabyte scale workloads, you can get into the billions, right? Very easily. And the discovery of that content is very difficult. The movement of that data from region to region, if not originally set up, nearly impossible, right? And the fact that you can get this data platform that literally abstracts you from the underlying foundation, right? And creates that portability, incredibly powerful. right? The fact that I know I'm going to be storing a bunch of data and I'm going to have a platform that's going to be doing all of the work for me. If I'm a researcher, if I'm a person that's solely dedicated to discovery of work, not being a storage administrator that gets paid 100% of the time, I don't want to be spending time moving objects to cold storage. I don't want to be spending time management and the management of like access controls, moving the data to the accessibility points. When you have a platform like WEKA, I feel like you're getting all of this all of these capabilities right out of the
It's
box.
spot on, and I'll tell you, I'm talking with some of our customers, and we're seeing more and more generative AI customers
Yes.
now. So I recently talked with one of them, and I asked him, "How did WEKA impact your work?" And his words out of the gate were, "You spoiled us." And I'm like, "Can you
I
elaborate?"
like
And
it.
he's like, "We did a lot of data engineering, which is, I think, the thing that you alluded to. Data had to be moved, copied. You actually literally had to go to the people that wrote code and teach them how to write code according to the storage, which obviously is non-scalable, non-doable, especially with new environments where you share them. You don't even know who's going to run code on your environment, right? So with the ability to say, hey, you don't need any data engineering. The system does it for you at scale. Just throw data into the system and it will work. That's spoiling users, and that's what we do.
I once had a developer tell me, Fabian, no offense, but I don't want to know anything about storage. I just want to use it. And that's exactly what I look for in platforms that are going to be next generation in cloud. How many features can you bundle in so that a ML specialist, an AI data scientist, is going to come in and focus on being an AI scientist, training models, and going there. In the route of talking about Gen AI, it's a
Yeah.
hot topic right now. Everybody wants to see like Chat GPT. I've built presentations myself where I say, hey, tell me everything I need to know about XYZ. It'll spew out a couple facts, pull
Yeah.
the ones that I like, and I turn around and say, okay, verified facts. Yes, we're good to go. And I mean, it's helping me. How are you seeing customers leveraging Gen AI, and how does that relate to what WEKA can offer in this new industry?
So we're actually seeing that there's multiple layers to that. So we're actually seeing a lot of the Gen AI workloads actually starting on the cloud, whether it's different cloud environments or whether somebody's creating their own cloud, but everything starts on the cloud. The cloud has massive resources for various reasons, right? And it's really easy to spin up and start. So the ability to say, hey, you can have a high performance data platform on the cloud, which is something that when you think about it is that you don't really have a lot of that. If you look at cloud storage options, they're still up to par with enterprises. You get filers, you get blocks, but you don't have massive environments that can support these workloads. So first of all, the ability to say, hey, Mr. Customer, you can start on the cloud, different regions, different AZs, different locations, is massive. That's one way of use. Another, it goes down to the data scientist. One, they have massive amounts of data. So I don't know if you ever, I imagine that you ever used a Jupyter notebook, right? So you open the Jupyter notebook, you write your code, maybe you're trying to chart some plots, and just the experience, and that's another some of the feedbacks that we're getting from our customers. That's the direct development feedback is suddenly my Jupyter notebooks is considerably faster because I'm running some code, and I get the visualization of that code simply faster by run because under the hood it's running on WEKA, so now it's not congested. More than that, they're now creating. If we look at regular AI versus Gen AI, the amount of data and the amount of replication and repetition of data is staggering. If we looked at gigabytes in some of the basic AI workloads to petabytes in some of the more advanced workloads, we're now looking at hundreds of petabytes and exabytes across Gen AI workloads, just due to the nature of them working and training the data. So the ability to say we can accommodate for that data and is massive. Also, if you look at the way that they're training the model, there's importance to how large the model is and how many times you trained it on different amounts of data, and you constantly add more and more data. So literally, if we can shrink the time to training, your epochs, if we can accelerate them 20x or 80x, there's immediate value.
I think that when we look at cloud, right, cloud's done a phenomenal job of abstracting the importance of that storage layer, right? I found that cloud, from its inception was kind of like storage is capacity, storage is either fast or slow, and make a copy of it if you need it, right? Very, very consumable, to say the least. But when you look at the complexity of workloads that are coming in, we understand that actually storage has a very important role in any sort of computational stack that we're going to be processing data in, right? We're going to be using storage to respond to any sort of request that we have. And that request, like let's look at a Gen AI request, right? If it's a model that has been asked to respond to certain elemental feeds that it's getting, what would happen if the storage is slow? Any stabs, right?
So usually you see that the model is either hiccuping or it's inaccurate if it wasn't trained on enough data. There's the hallucination part, right? You want to avoid that. So usually inferencing in Gen AI, and that's a bit different. Inferencing in Gen AI is mostly streamlined. So I have a model, it's loaded, I'm streamlining the data into it, and it's inferencing in real time. The thing is that sometimes you need to switch models because obviously a single model can't accommodate for everything. So now there's suddenly the latency of switching a model while you're working and inferencing in real time, right? So I now need to load terabytes of data of the models, not of the data, to accommodate for that. So there's the importance of that as well.
Yeah, I think that, when you're running these models, you're going to be seeing what we're going to begin to look at as like, oh, the model's thinking, right? But why is it thinking, right? Is it because there's so much data that it's aggregating it all? Or is it thinking because there's a bottleneck somewhere, right? And that bottleneck may be storage. And do you want that model thinking for a long time? Well, who knows? Maybe you're just watching and you're like, hey, who won the Academy Award for this one particular show the last 3 years? And it's going to go out and think for a little bit. But if you want the model to give you a quick answer, like, I have these particular medical symptoms, what medications align to addressing this, you don't want that to be thinking for 20 minutes, right? You want quick responses.
Brilliant. Yeah, no, it's very important.
Yeah. I want to also talk about now that we're talking about this whole new Gen AI, there's this sudden demand and deep interest in artificial intelligence, the building heavily on automation and all that. And really, when you look at the industry, a lot of them focus on how can we get you results? How can we get you what you're looking for? Whether it's a chatbot agent that you're going to call and say, hey, my product wasn't delivered, all the way through like self-driving cars. But, and I'm sure that you encounter this a lot, we don't really hear a lot about the back-end infrastructure that houses these computers, right? That are going to be using GPUs, that are going to be having distributed storage on its back end, that are going to democratize and make the data accessible. So as we leverage this, I'd like for you to give us your perspective, because I think that you're the right platform to get us there, and how you think that infrastructure is going to influence AI in the future.
So there's the notion of, especially since a lot of these environments begin in the cloud, of infrastructure as code. So if I'm, first of all, there's the cost aspect of it. If I'm now running an AI workload, obviously I want to pay as much as I need to maximize my results, but not more. So everything is orchestrated, everything is API based. I'm scaling out my virtual compute environments, but I need to also scale up and down my storage capacity. So for example, with WEKA, one of the neat things that we do is the ability to respond to that storage as API, storage as code. Just send us a few APIs, say, hey, WEKA, double, triple, quadruple, or completely shrink, or maybe evaporate completely while still retaining the data. So I think the cost management aspect of it is significant, especially when you want to scale in the cloud. And it's frankly, it should be hidden. It should just work. And as you mentioned,
Yes.
And what we're seeing also, we're now seeing different types of silicons, if we're talking about the future. So currently, GPUs are heavily being loaded in GCP. TPUs are being used heavily. There's other silicons that are being created. So I think we're going to see, and we already are seeing, a plethora of other silicon accelerator environments, and also other libraries and methods of consuming the data. I'll mention one of these, which is out there for a few years already, GPU Direct Storage, for example, which is an API by NVIDIA to consume, to consume storage directly by the GPU and the GPU HBM. So a GPU is now issuing an API call directly to the storage, and the data gets planted in the GPU HBM directly. We fully support that, by the way. The value of it is also obviously the massive performance that it provides. And again, with WEKA, you'll get the throughput, IOPS latency, and metadata performance that comes with it. But also there's a green aspect to it, because, and I think that's as important, because, retaining the planet, saving the planet is as important as running GPUs that are very power efficient. So anything that you can do that will significantly save on that is important to us as a company, and I think to us as humanity. With that protocol, you're using less CPU cycles, less memory. It significantly reduces your compute power. So that's one of the advantages that we really appreciate here. And talking in general about, and I'm sorry, maybe I'm rushing into the next subject, but talking in general about sustainable AI, I think that's becoming more and more of a big thing that is interesting. If you look at a lot of CIOs' objectives for the year, there's a lot of green cloud, green objectives. How can you prove that this is a green solution that actually is helping us? Because again, we're doing so much, these GPUs are using so much electricity. How can we offset that? So with WEKA, I'm really proud to say that we've done a lot of research, and actually there's a lot of third-party research on us that we're fully supporting that.
And that's fantastic, because as we're transitioning, right, we're going to be seeing more consumption of data, more consumption of compute, but we also have to be very responsible about how we do it. And it isn't just being responsible because, hey, it's going to overrun my cost, but it's the overall impact of environments, right? How much electricity am I consuming, and how is that going to impact humanity, right? It's questions we should absolutely be asking ourselves.
I'll give you another thing on that, because I'm sorry, but it's super interesting. Because of the ability to say, hey, I can run on any cloud AZ, for example, but also provide storage as code, we're now looking into sustainability APIs on the cloud. So I'm a customer. I need to run my storage and my compute somewhere. I can say, hey, I want to provision it on a most efficient clean data center at the current. And maybe today it's in East Coast, maybe tomorrow it's on West Coast. I shouldn't care, but now I'm powering a solar-powered data center. So because of the ability to say storage is code, compute is code, just run the sustainability API, will provision the code wherever it's needed, wherever it's most green.
Yeah, that's fantastic. It's having it. Well, it's what we talked about earlier today, right? It's portability, right? I can port my data where I need it, right? Extending on portability, there's a question that I think is interesting. I've worked a lot with data scientist teams, BI teams that collect massive amounts of data, and then they hand them over to BizOps. And then you end up having partners that come in and say, hey, do you have these data sets? Can we leverage some of your data sets to do XYZ activities, right? And sharing data is a very complex thing, because, you got to put NDAs in place. There's security aspects of all that. But when you start looking at AI, you start looking at this massive collection of data that some of it will become private intellectual capital, but some of it will be publicly accessible, right? How does WEKA uniquely position to be able to democratize data sets?
So with WEKA, you have the flexibility, as I mentioned, to chunk the data into different data sets, to access that data in different protocols. So it's very easy to say part of my data is accessible through one protocol or another. And then I can even, by the way, we fully support encryption of the data, so you can fully authorize your own data where only you can access it. But you can say part of my data is shared over another protocol, and here's a one-time access key to that data only. So you can only use that in a certain protocol in a secure fashion. So we can definitely use that to share data. We can even send the data to another location, because if I'm now I'm a research environment and I want to share my data with a remote research environment, I can just say, hey, WEKA, move the data to their environment so they can utilize the data in a secured, authorized, actually individual way. And then they can actually send me back any outputs using their environments to my system if I so authorize it. So now I have their outputs and their insights.
How about API integration, right? Like, let's say I'm a developer. All I want to do is just access and pull data. Can I use an API just to get in there and be authorized to extract content?
So we do support APIs. We do support as I mentioned, the GPU direct storage API. Currently, other APIs would be through the other protocols. An exciting thing that we're working on is actually to have an API-based only access.
Phenomenal.
This is something that we're planning, still not in the product. I'm being technically direct here, but this is something that we're seeing more and more. Some users are saying, just give me a PyTorch library and that's it. I don't want even a mount point. So
Okay.
it's easy for us to do it.
I like the answer, right? It's the forward thinking. You know what I like about it, Shimon? When I need to do that as a customer, I'm not going to have to re-architect my environment. It's feature capability enablement, and now I'm ready to go, right? Which brings me to sort of our last question here, right? There's a lot of storage players out there. The industry is massive. It is $1 billion. I think the storage industry is what, 25, $30 billion annually, if not conservatively. So there's lots of players out there, lots of names that we know that we've kind of grown up from the times of like Big Blue all the way to today, the most innovative freeware that you can find out there, right?
Yeah.
What's making WEKA so unique and distinct from everybody else in the playing field?
So I think if we're looking at a lot of the other storage player environments that are out there, they've all grown. And again, a lot of respects to all of them. All of them solve some problems or have solved a problem when they were created. So if you look at technology, hardware technology, networking, flash devices, accelerators, they all go in a certain way. And then you look at software and cloud going in another layer. So the unique thing that we did is when we designed WEKA, actually a lot of people told us, you came to the market even a bit too early. You actually were in front of the AI hype or the AI wave. So we designed WEKA in a way that it would adapt to modern environments, not to the yesterday or the today environment. So for example, the ability to say, as a file system, we can accommodate for all type of IOs. That's a mind shift to a lot of the file system guys that are saying, no, you should be only IOPS or throughput, or no, WEKA can handle all of them. Throw this, and we're spoiling our user. Just throw all of the data on WEKA. That's very unique. It's very differentiating. The ability to say, we can manage that data and scale, and we can move it. Let's say that we have an on-prem environment and you want to throw the data to the cloud environment. We can do that for you, and then you can run the data on the cloud. So the ability to orchestrate the data with the storage environments in the same API. It's the same executable, actually, that's running on-prem and on the cloud. It's not a different product. So your orchestration works here and here. So that's very unique. The multi-protocol access also. Sorry, you were.
No, you're great. You're good. I mean, when I see these platforms, right, and I see a very innovative platform like yourself, you're pushing the limits of where we are in storage today, right? This is the cutting edge. And we want to make sure that we're there, right? Why is it that SADA came in when we saw the value proposition of WEKA? Why did we get so excited? Well, it's the fact that it provides that bridge between object NAS at a petabyte scale with the performance that you need. And I mean, you can run this 100% on Google Cloud, right? Or if you're not,
Definitely.
if you're doing a blend that you need to generate content on-prem and then extend to cloud to do further analytics, this does it for you. If you're looking to like keep a bare minimum footprint on-prem and move the content for archive or tiering, you can do that into Google Cloud very easily. The network with Google Cloud, I know we say this all the time, but it's what gives you that power, the concept that I can go and put content in archive tiers in object storage and then call it back with the exact same callback time that I have in regular Google Cloud storage, really allows you to even take like an auto scale bucket and use that as your tiering tier, right, for WEKA. And automatically the objects are managed within WEKA, but they're living in a cloud storage bucket that has auto tiering behind it. So the cost of ownership can really go down over time.
Completely.
I mean, and so we started seeing these things and we're like, wait, we have customers in the life science space. We have customers in the EDA space, in the HPC space, that this is what they're looking for. A lot of times what holds them back is portability of the data into cloud, right? And so for us, it was real phenomenal. And it's been a total pleasure working with your team, right? We've already worked with multiple customers. We've sat down and developed joint architectures on, you leverage our expertise on how things should run on Google Cloud and how they should extend from on-prem to cloud. We've come in and said, okay, these are the needs that the customer has. You've come in, also validated the needs. What's the experience been like when you've worked with SADA?
Brilliant. I think you're one of our most valued partners. We went with you. Actually, one of the things that we did together is put WEKA on the Google Marketplace together, right? And put SADA and WEKA on the Google Marketplace. It's been a pleasure. And I know that we have phenomenal channel people that are working with your side of the group, and they have very good ties. And actually, it's very easy and fun to work together. So thank you for that.
No, thank you. And I think that there's a lot of value, right? For example, you mentioned the marketplace listing. There's multiple reasons why that's important, right? So if you're a customer, you've got a Google Cloud commit, you're going to go spend and say, hey, SADA, can you help us with the management of WEKA? Can you help us with the deployment of WEKA? Can you help us with the migration into WEKA, right? We become that professional services delivery team for you and management team, right? And obviously it comes with, a cost because there's our resources that are on your side helping you, right? But when Shimon's mentioning that we were able to build a joint market offering on Google Cloud Marketplace, it means that you can purchase your WEKA licensing and SADA professional services into a single purchase order through a private offer and transact it all through the marketplace as one single bill, right? And then from there, you can then leverage that private offer and the consumption, the dollar amount that is tied to it, and it counts against your commit. So we're setting it up to where not only are you getting the platform that's consumable, that's going to be the partner of choice for you for your next generation data storage platform, but the way in which you're going to consume it also has direct tie-ins to benefit you, right? So we want to make sure that we're always very customer centric. It's a mission here at SADA for us to always be vested in the best interest of the customer. It's why we handpick our partners like WEKA, and we form these partnerships and marketplace listings to benefit you every single step of the way, right? Shimon, anything else that you want to add?
No, this has been an absolute pleasure. Thank you.
I really appreciate your time here. I think that one day we should sit down and really begin to share kind of like those, PTSD storage stories that all of us have, right? At some point in our career where you realize that like, holy cow, something went awry and we had to fix it. And all of those experiences have been what has helped us either architect, develop partnerships, or even like yourself working for these storage platforms, right? That have really come through and revolutionized the next way we were going to do storage.
Brilliant. Definitely.
Right. Thank you very much, Shimon. Look forward to our next conversation. Catch us on our next episode. It'll be another exciting topic, as you can imagine. So thank you very much, and we'll see you later from the SADA team.
Cheers.